my name's Mackenzie.
And I'm Michelle.
And this is our
Home Lab Experiment!
So what are we doing today?
Our goal is to prove that if an object starts at the same height with an initial velocity of 0, then the final velocity will be the same, regardless of the path it takes. The law of conservation of energy states energy can neither be created nor destroyed. Rather, it transforms from one form to another.
So since the change in energy is 0, the final energy minus the initial energy must also equal to 0. Therefore, this means that the final energy is equal to the initial energy.
Things you will need: a marble or ball,
2 tracks,
measuring tape,
a slow motion camera,
and a stopwatch.
Let's get building! I can't do it!
5 minutes later.
We previously stated that the final energy is equal to the initial energy.
In this experiment, there are 2 forms of energy present: kinetic energy and gravitational potential energy.
When you combine these 2 energies, you get the total energy. By combining these 2 equations, you get the equation shown in pink.
To simplify the math, we can assign the final height, aka the ground height, to be 0.
Since the initial velocity was 0, this entire term can be taken out of the equation. Therefore, this can be simplified to the equation shown here.
Since the mass of the ball is constant throughout, these terms can be taken away from both sides of the equation.
Lastly, you must rearrange the equation to isolate for final velocity.
We know that the acceleration of gravity is 9.8 meters per second downwards.
We measured our initial height to be 19 inches.
We have a problem.
We can't forget to convert.
Since we know 1 inch is approximately 2.5 centimeters, you must multiply that by 19 inches to get 48.26 centimeters.
Now we must divide this number by 100 to get a value of 0.4826 meters. Don't forget your significant digits.
By plugging these numbers into our equation, we get a final velocity of 3.1 meters per second. During our experiment, we measured the time it took the marble to travel a distance of 0.7 meters at a height of 0.
In the 2 cases, the times were slightly different, resulting in the 2 velocities to be close in value.
Why were these velocities slower than we expected? Are we making any assumptions in our calculations? Yes.
We assumed that the track was frictionless, when in reality, friction acts upon the object.
This is why our experimental speeds were slightly slower than expected.
So in our experiment, case 1 and case 2 velocities were both slower than those obtained in theory. However, case 2 was the slowest of them all because it had a longer path, and this allowed for a longer period of time where friction was acting upon the object.